Welcome back to the floor of AWWA, where we're talking with Jeff Turner, an expert in all things fusion from McElroy Manufacturing in Tulsa. Welcome, Jeff. Nice to see you.
Thank you, Peter. Thanks for having me.
So there have been a lot of changes here in the industry as it relates to accountability. And one of them, and I was lucky enough to take a class from McElroy in butt fusion, and I received my card. Could you tell us about the card and how this card helps the engineer when he's or she's interested in making sure this product goes into the ground properly?
Well, one of the key aspects of having a quality fusion and creating a quality process is having a certified technician. McElroy University puts on several different courses in certifying contractors for small, medium, and large diameter fusion.
Okay.
Also, our distributors can do the same thing, put on the same different courses for...
So you actually train the distributors to the level that your guys taught me?
Absolutely.
Awesome.
Yes. So we have certified instructors that are all out throughout the country. We have certified instructors in Tulsa, where McElroy is based, and we can certify technicians all across the country to make sure there's accountability and quality fusion technicians on job sites.
Awesome. Tell us about this card and how that works.
Once you are certified as a technician, you will receive a fusion technician card for small, medium, or large diameter fusions. We'll actually list the products at which you are certified to fuse with.
Awesome.
Yes.
So I assume they would write this into the spec that the operator has to have been qualified to, what is it, ASTM F2620?
Yes, and ideally you're going to want a fusion technician that is certified. And if you want to write that into a spec, you need to make sure that they are required to be certified through a process that has a national standard base to it, and which our McElroy University schools do have a national standard, yes.
So what's something else that an engineer can do to make sure that that pipe goes into the ground properly?
Well, when you look at having a certified technician, that's your first step. Secondly, you also want to make sure you have distributors and partners who are keeping their products in great shape. And we have certified McElroy rental partners who can do that, who make sure that they keep their equipment in top-notch condition so the machines come in, are inspected, and are inspected before they go out.
Okay.
So that's a second key part of the process.
So we have qualified operator, we have qualified equipment. What's next?
Lastly, if you want to really make sure that your technicians are accountable on the job site, our data logger product is a perfect capstone to those other two items. Now, awesome. The Data Logger 5 here is going to provide you with data throughout the process that will track the timing and your pressures through your heat soak time and through your cooling time. And once that is complete, all that data that will maintain who the operator is, it will maintain what equipment that you used, it'll maintain the fusion pressures, it'll maintain the timing at which you fuse these things. It will upload it to a cloud called the Vault. That Vault will hold that information in perpetuity, forever. And once that is uploaded to the Vault, whether it's someone across the job site or someone across town or someone across the country, they can immediately look at that joint report to make sure every step in the fusion process was done with the appropriate fusion and the appropriate times.
Awesome. So I've heard contractors initially didn't like this idea because it added steps to the process. What are they saying now?
Well, it's really not adding steps to the process. It's just a part of the process itself, and it helps walk you through those steps at which, whenever it's time to open and close the machine, or when it's time to go into the heat soak, or when it's time to go into the cooling time, it actually helps direct them in a way. Yeah. So they appreciate it because they also know that the owners and those who track the fusions are seeing that they, as a certified technician, are following the appropriate steps during the process.
So I've also heard that the engineers who sometimes their contracts don't let them go out on the site, every day, but fusion's going on every day.
That's right.
That they can see what's going on remotely.
Yeah, what's great about that is an engineer can be at their office and not have to take the time to go to a job site. They can be at their office and know that all the fusions are going to be uploaded to the database by the end of the day. And when that happens, they can check each and every fusion see where it was from a GPS tracking standpoint, see what the name of the joint is, what number it is, what the name of the project is, and they can determine whether they're satisfied with the process at which that fusion technician fused that pipe. And if they're okay with it, they move on. If not, they might pick a couple of joints to possibly cut out and redo. But the great thing is it saves time and money because they don't have to worry about knowing that something might have been not done right at a later time, like when they pressure test or when a line goes live.
So basically the engineer signs off on it, or the inspector, before it goes in the ground.
That's
so there's still time to cut it out and fix it.
Absolutely.
If they did something wrong, generator cut out or something like that.
Absolutely.
Very cool. All right, Jeff Turner, thank you very much. We'll see you all next time in our next segment. Welcome back to the floor of AWWA. Now I welcome Jeremy Harris, Product Manager with Plasan USA.
Great, thanks Peter. The newest innovation from Plasan is our universal slip repair coupling. This is a compression coupling that will work great for plumbers in the field when trying to do those difficult repairs.
So how does that work? I mean, and what kind of pipe types does it work on?
The great advantage to this particular fitting is that it will actually work with a number of different pipe types, from HDPE to copper, PVC. It'll also work on a number of different diameters of pipe. So we could go out with a plumber may not always know what size diameter pipe he's going to work with. It'll work within a certain range. We have 5 couplings that will cover a range from 3/4 inch to 2 inch pipe sizes. And we actually have a gripper ring that's on the inside of the fitting that actually attaches itself to the different pipe types and then compress against the O-ring to attain a seal.
Very cool. And what kind of pressure ratings do we have, Jeremy?
It's actually still fully pressure rated. It's rated to 200 PSI.
Very cool. And is that available now?
It actually is available at the end of the month, so 1st of July we'll hit the ground running with the Plasan Universal Slip Repair Couplings.
Awesome. Thanks, Jeremy. Back to the floor, and thanks for watching. Welcome back to the floor at AWWA, where the Alliance is pleased to welcome Richard Brand, who's the Executive Director of the East Windsor Municipal Utility Authority. And Richard has adopted the use of HDPE for all of his projects in town. And tell us a little bit about that and your decision to go with HDPE, Richard.
We were finding out that we had some problems with our ductile iron. We found out that the soils are corrosive, and some electrolysis has been taking place also. Which has been deteriorating the ductile iron from the outside in. By knowing that, we went out and investigated, looked into all different materials. We found that HDPE was best suited for our needs.
So you were having shortened life with your metal pipes.
Absolutely. We found that the life cycle of our ductile iron was approximately 40 years.
40 years, okay. And tell me a little bit about your unaccounted for water. You know, with the deteriorated metal pipes, I'm sure you were losing a fair amount of water.
Absolutely. Our unaccounted for water was about 9%, which is still way under the AWWA standard of about 15% nationally. But with our system being as young as it is, the unaccounted for water should be very low. But once we found out that our main breaks were either circular breaks by thermal expansion of the soils, or the corrosivity, which was a big major part of our water loss. At that point, we determined to replace several streets, which we have, and since we've replaced them, we've realized that our unaccounted for water now is down around 6.5%.
So you went after the low-hanging fruit first?
Absolutely.
Yeah. So you're seeing a lot of breaks there, and you use those projects as your. So you've done a few poly projects now.
Yes, we have.
Yeah. So both jobs that you bid out.
Yes.
Right, and that's for your normal capital plan, and then you're also using it for new construction.
Yes.
Tell us a little bit about that.
With the new construction, we require all of our new development now to put in HDPE. Again, due to our soil conditions and our past experience with the ductile iron, we decided to put it in our specs now that all new development will be of HDPE DR11.
DR11. And the contractors are embracing that?
Yes, they are. Actually, the other day I was out on the job site talking to a couple of the contractors that are doing the work, and they were very surprised and very happy at the ease of installing the HDPE. We put in approximately about 3,500 linear feet. It took them about a week to do the installation, where if it was ductile iron, they'd still be out there today installing it.
But that's one project. You've done other projects as well,
Yes, we have.
right? Okay.
Yes, we have.
Any advice you have for other directors of utilities as they embrace this polyethylene epidemic?
I highly recommend it. I think it's one of the best products out on the market today. If I didn't, I wouldn't be doing it. So I believe in it, and I think it's I think you're going to see more and more people go towards the HDPE.
Thank you, Richard.
You're very welcome.
And thanks again for watching, and we'll see you next time on the floor of AWWA. So now on the floor at AWWA, I welcome Stephen Burrows, Vice President of Engineering with Pipeline Plastics. Stevens, you were telling me off camera, recently there have been some new developments to come out in the standard side of the municipal polyethylene world.
Absolutely, Peter. It's really very exciting that we have the most up-to-date standards available now with C906 and C901, cover both large diameter and small diameter piping.
Awesome. Now that C906 has been around, why does the utility care about C906? What impact does that have on the industry?
You know what's the most important part of C906 is it utilizes the latest and greatest in polyethylene technology for the piping system application. So you can utilize the immense toughness of polyethylene and PE 4710s that the standards didn't recognize before. So now utility can get much more efficient in their design and practices and usage of piping for water distribution by the use of these new standards.
Awesome. And now, what does 901 apply to, and why do we care about that?
Well, 901 covers the service sizes, so up through 3-inch diameter. So when you're doing a service lines for polyethylene, then you have a lot more rigorous installation requirements because it's not buried as deep. It's usually not designed as rigorously as a distribution main would. So you need the robustness and toughness of these 4710 materials to give you a full 50 to 100 year service life these products can give you.
Awesome. I also hear that PPI is coming out with a modeled spec that covers the full spectrum of polyethylene use for utilities.
Yeah, they are. So one of the things that PPI likes to do is education. And so the thing is PE Alliance is very good at. But if you don't understand how to design and what to ask for with polyethylene piping systems, the model spec will give you a good base to start from. So you can now integrate all of these important concepts into your individual system and how it can work best with how you operate and how do you go about specifying materials.
Great. So what other standards or specs or industry tools should a utility be aware of as it relates to their use of the product?
Well, it takes more than just pipe to make a system. So you have all the fitting standards that go with it. You have the butt fusion fitting standards. You have the electrofusion fitting standards, as well as all the mechanical options that go with it as well. So all of those are becoming to be in place. And the next thing we really need to focus on is repair of the system. So there are all the repair couplings and repair practices out there. We just want to educate people and get them knowledgeable in that so they're comfortable that when a situation happens, they have the tools necessary to go out and repair these systems.
Great. Good job, Stephen Burrows. And until next time, so long from the floor at AWWA. Welcome to another edition of the Alliance for PE Pipes Floor Series, where we're on the floor of AWWA talking to various experts about HDPE. With me is Dusty Langston, an engineer with WL Plastics. So Dusty, you and I have been working together quite a bit over the last couple of years. Tell us from your perspective what some of the trends are in the adoption of HDPE.
It all started out with getting our foot in the door. Most of the time that's with a horizontal directional drill or that's with a pipe bursting application. But the biggest benefit to that has been that their neighbors are now using it. Cities next to cities, people talk to each other, and now we have greater adoption across the board because these cities talk to each other.
Right.
And so places like San Jose, California, Palo Alto, Lago Vista, Texas, Miami-Dade, Florida, New Jersey, a lot of these states and cities, when they start to use it, word spreads. other people start to understand and they see the application and the benefits of those applications.
So we see that, Palo Alto in the South Bay area started using it, so other utilities use it. And now Google and Apple and Tesla have used it for all of their site work. So, some of these innovators it's going into corporate America. So it's like going from municipal to corporate. It's kind of weird, right? It's usually the other way.
Completely opposite, yeah.
And also in Texas with, their drought issues over the years. Tell me a little bit more about the Lago Vista that you brought up.
And it's not just Lago Vista, it's the city of San Jose, it's East Bay Mud in California. They're worried about ground movement. They're worried about years of sustained drought that they've had and the amount of movement the ground has during those drought cycles. And that really plays into HDPE's benefits of being so ductile and so malleable that they can move with ground movements. If you have drought and ground swell when you get water in it back in it, you have a lot of ground movement, and HDPE pipe can move with that.
Right. But what was Lago Vista's issue? Why did they end up going all poly?
They actually had a leakage rate very, very high, over 25% leakage rate. And they decided to really get on top of that by using polyethylene pipe. And now in just 10 years of using polyethylene, they've dropped their leakage rate to below 10%.
Wow. Yeah, actually, I think their leakage rate I've got right here was 36%, and it dropped down to 12% in just 7 short years of using the product. Now, you also brought up Miami. Tell me about what happened in Miami and why they've gone toward HDPE.
Miami was another one. They wanted to see how they could replace piping systems for the least amount of money. Every municipality needs to know this. Everybody tries to do it. They came in with their sewer systems to replace their sewer systems with polyethylene, and they're now the largest replacement project using pipe bursting in the United States. Is
Awesome.
Miami-Dade.
Yeah, and then just north, we had the Miami Beach, that record drill last year.
Yes.
Tell us about that project.
We actually, right here on the floor today, since it's the floor seminar, we're showing videos of this directional drill. It is now the largest and longest diameter horizontal directional drill ever accomplished. 54-inch HDPE pipe. Full length of the pipe was 3,200 feet.
3,200 feet, and actually in 2 separate drills.
Just 2 pulls.
Yeah, at a
did
depth
that whole
of
job.
At a depth of 40 feet. Think about that. We also got to know Richard Brand up in New Jersey. The kind of the Rust Belt states and the heavily industrialized parts of the United States have been slow to adopt polyethylene. But we get places like East Windsor Municipal Utility Authority. Tell me about their use.
Yep, East Windsor, when we get into the Midwest, Livonia, Michigan, very, very slow to adopt, these newer materials, even though we've been out for a long time. They are very heavily still metallic pipes. But once we get in there, they understand the benefits of pipe bursting, they understand the benefits of polyethylene pipe, and really once they adopt, they become very strong adopters.
Thank you, Dusty Langston, and we look forward to next time on the AWWA Floor Series. Thank you.
Thank you.
Welcome to another edition of the Alliance's AWWA Floor Series, where we talk to various experts in the HDPE industry about polyethylene and its municipal adoption. This is David Fink, Vice President with WL Plastics. So David, you and I have been working together quite a bit over the last few years
Definitely.
with HDPE. What's some of the more interesting developments that you've seen and the impact those have had on the market?
Well, what we're really seeing, Peter, in the municipal water and wastewater segment is people getting tired of the same cycle of materials that are aging. They're at the end of their lifetime, they're breaking, they're putting Band-Aids on it. They don't have a sustainable solution moving forward. We're really excited about some of the innovations that have occurred on the polyethylene resins over the last decade that are now being introduced to these municipalities. Most municipalities only replace less than 1% of their piping infrastructure a year. Do the math. They need over 100 years out of that new pipe whenever it goes in the ground. These newer resins that have been in the industry now for the last decade can provide that. It's a nice, great, sustainable solution.
So tell me about the resin and, what's the salt and pepper, what's the black?
Sure.
What is that?
So the black is what we use, and you can see here a finished pipe section that actually adds both physical strength and characteristics and then unlimited outdoor storage. The carbon black, which is the black in the resin.
The carbon black?
Carbon black.
Okay.
offers unlimited UV protection. Fancy way of saying you can put it out in the sunlight and it's not going to corrode
So
or
it's
be
like
destroyed
after
over
12
time.
months, you don't have to worry about it.
After 100 years, you don't have to worry about it
Really?
outside. So it's sustainable to be above ground. So if you have a bridge crossing that you want to hang the pipe from and suspend it, you can leave it there and it'll still give you your 100 years of lifetime.
Awesome. Okay, so we have longevity.
Yes.
We have utilities suffering from significant water main breaks and failure. You know, we see 240,000 water
Correct.
main breaks a year. So how can HDPE help that process?
Well, it's a different material from the rigid materials that are out there today. A lot of the heritage materials are very rigid, so as the ground moves, whether that be clay shrinkage and expansion, if it's ground movement due to earthquakes, polyethylene is extremely robust and slightly flexible to where it can move and maneuver itself with the ground. Great impact strength, which also helps it when you have issues like water hammer. So utilities that are valving on and off throughout the day are causing some water hammer effects. Those rigid materials don't handle it well. Polyethylene has got over 10 million cycles without any failures. That again gives us that 100+ year longevity and durability because of its toughness.
So on this piece of pipe that you just showed us, it's got blue stripes on
Yes.
it. What does that mean? And
So the beauty of polyethylene is we can color code for different municipal segments. So on this one, we have two things here to show. One, we put blue in as a stripe. It's also the polyethylene material to signify potable water. And then every 2 feet, we have a print line on it that identifies from cradle to grave what material was used, what manufacturing site it was made at, what manufacturing line, what shift. So if there is ever an issue out in the field, we have full credibility from where we bought our resin the whole way through to where it was manufactured.
so if a utility were looking at this product, who would they go to learn more about it? You know, what resources do we have available for them?
Obviously the Alliance, so let's start with us.
that's,
the whole reason we were formed was for education and promotion of this product.
Right.
And then you have your members within the Alliance. So the pipe manufacturers do not sell direct to utilities. We go through a host of distributors that are throughout the nation. Guarantee there's probably one in your town or nearby your town that you can contact. So I would promote that they look on the Alliance website and find some of the distributors to call and ask questions
Awesome.
about polyethylene
So
pipe.
that is www.pepipe.org. So that's pepipe.org. And you can find WL Plastics there, and
Yes.
you can find any of our other 95 members on our website. So David, thank you very much.
Thank you,
What a
Peter.
pleasure to see you today, and we'll see you in the next segment. Welcome back to the floor of AWWA, where I'm meeting today with Dave Stewart from Lago Vista, Texas. Dave is the Assistant Public Works Director. So Dave, tell us, if you would, about your first experiences with polyethylene and why you decided to start using it.
Well, we were using it in a subdivision that was real close to the lake, and the water purveyor wanted us to put in a leak-free sewage system. So we went with HDPE pipe for that application. While working with the pipe, we decided to explore the possibilities that would work well as a water system. And about 2.5 years later, we started converting our entire system over to HDPE.
So 8 years is how long you've been using it, I understand?
Yes, we started in 2009.
So what kind of impact on your system has your use of HDPE had?
With the multiple uses that we've done with the HDPE, we've managed to reduce our water loss from 35% down to 12%.
I understand some public agencies have recognized your efforts as kind of a best practice in the state of Texas. Tell us about that.
In January, we received an award from the Texas Water Development Board for innovative water conservation, followed by the Water Conservation Advisory Council's award for water conservation. And then we recently received the Texas American Water Works Association's Water Conservation and Reuse Award last month.
Wow. Well, Dave, that's really exciting, and congratulations on all that recognition for your hard work in Lago Vista. So here we are on the floor of AWWA. Dave Stewart, thank you very much.
All right.
We'll see you again soon.